Which planet in the solar system do you think is the loudest? Now you might be inclined to point towards Earth with its bustling cities, roaring traffic, and the ceaseless chatter of over 7 billion people. Surprisingly, you couldn't be more off the mark. Despite our best efforts, Earth is a mere whisper in the grand symphony of the cosmos. So who's the loudest performer on this cosmic stage? The honor goes to none other than Jupiter, our solar system's largest planet. Yes, the massive gas giant that's over 20 times the size of Earth is also the noisiest. And no, it's not because Jupiter is full of rowdy alien parties. The reason for its loudness is as fascinating as it is unexpected. It has to do with something called radio emissions, but more on that later. That's right, the big gas giant that is more than 20 times more massive than Earth is the loudest planet in the solar system. But why is Jupiter so loud, you may ask? Well, it's not because of a monstrous orchestra of alien musicians, but something far more scientific and intriguing: radio emissions. Radio emissions are electromagnetic waves, invisible threads of energy that can travel unimpeded through the vast expanse of space. These waves can be picked up by radio telescopes both here on Earth and in the great beyond. Now, Jupiter is a maestro when it comes to radio emissions. This is due to its powerful magnetic field, a force field that interacts with charged particles from the Sun and its many moons. These interactions, like cosmic sparks, create an abundance of radio waves, which when picked up by our radio telescopes sound like a cacophony of noise. Now, measuring this noise is where it gets interesting. On Earth, we use the decibel scale to measure sound. If we were to apply this scale to Jupiter, it would register at about 1,000 decibels. To put this into perspective, the loudest sound ever recorded on Earth was a volcanic eruption in 1883 that reached 180 decibels. Anything above 194 decibels would create a shock wave of sound so powerful it would obliterate everything in its path. However, decibels don't really translate well to space. There's no air or medium for sound waves to travel through. Instead, scientists use a different measure: power flux density. This measures how much energy per unit area per unit time is carried by a wave, and it's measured in watts per square meter. With this measurement, Jupiter has a power flux density of about 10 to the power of 14 watts per square meter at a distance of 1 astronomical unit. That's the average distance between Earth and the Sun. In terms of power per unit frequency, or hertz of bandwidth, this equates to about 10 to the power of 8 watts per square meter. That's an astronomical amount of power and a lot of noise. So, using power flux density, Jupiter has a power flux density of about 10 to the power of 14 watts per square meter at a distance of 1 astronomical unit. That's why Jupiter, and not Earth, is the loudest planet in our solar system. Scene script. How loud is Jupiter compared to other celestial bodies? Let's put things into perspective. When we measure the power flux density, which is the energy carried by a wave per unit area per unit time, Jupiter's intensity is astronomical, no pun intended. Imagine this. The Sun, our very own star and the powerhouse of our solar system, has a power flux density of approximately 1,000th of a watt per square meter per hertz of bandwidth at a distance of 1 astronomical unit, which is the average distance between Earth and the Sun. Now hold on to your seats because here comes Jupiter, the gas giant, the heavyweight of our solar system. Jupiter has a power flux density of about 100 trillion watts per square meter at the same distance. That's equivalent to about 100 million watts per square meter per hertz of bandwidth. In simpler terms, Jupiter is about 100 billion times louder than the Sun at radio frequencies. Yes, you heard that right. 100 billion times. That's a 1 with 11 zeros after it. It's an unimaginably large number. But here's the twist. Despite its deafening loudness, we can't hear Jupiter's mighty roar. You might ask why not? Well, that's because sound, as we know it, requires a medium like air or water to travel through. And space, my friends, is a vacuum. There's no air or water in the vast expanses between celestial bodies. So, while the sound of Jupiter is lost in the vacuum of space, its radio emissions are not. They travel through space and reach us here on Earth. Our radio telescopes pick up these emissions, convert them into audible sounds, and voila! We get to experience the mighty roar of Jupiter, the loudest planet in our solar system. So while you can't hear it with your ears, the radio telescopes tell us that Jupiter is the loudest planet in our solar system by far, a noise that would blow your mind and your eardrums if you could hear it.